Hi children, today we are in the last session of chapter 2 rational numbers. In this session we are going to discuss few more properties on rational number, how to locate rational numbers on a number line and how to write any two rational numbers when two rational numbers are given. Okay. Observe here, what to be added to get 0? What number we have to add to 5 to make the value of 5 0. We know on number line 5 comes towards the 5 units in the positive direction of 0. Okay, this is the place of 5. To make it 0, I have to come back 5 units towards 0 in the opposite direction of positive direction. Yes, observe you here. Now I am going towards 5 from 0 by crossing 5 units. To come to 0, I have to come back 5 units to reach 0 in the opposite direction I walked. Yes, that means I have to add minus 5 to 5 to get 0. One more thing, what should be added to get 0 to minus 5? So, to make minus 5 0, we have to add plus 5. Yes, like that. What should be added to minus 3 to make the minus 3 value 0? Observe, minus 3 means I am going 3 units backward, that means towards negative direction from 0. Okay. This is minus 3 position. To make this minus 3 to 0, I have to move 3 units towards positive direction. Yes, that means I have to add plus 3 to minus 3 to make it 0. If I reverse this, what should be added to 3 to make it 0 means I have to add minus 3 to 3 make it 0. Here minus 5 is called additive inverse of 5 because I am getting identity element 0 of addition. Yes. In the same way, minus 3 is the additive inverse of 3 and 3 is the additive inverse of minus 3. Okay. So, let us discuss about this additive inverse in detail. Okay. Observe here. What should be added to make sum 0? Here 2 by 3 is there. Yes. What should be added to 2 by 3? Now I am taking rational number example. What should be added to 2 by 3? To make it 0 means I have to go back 2 by 3, 2 units 2 by 3. 2 by 3, 2 parts I have to go back to make it 0. Hence, minus 2 by 3 is the additive inverse of 2 by 3 and 2 by 3 is the additive inverse of minus 2 by 3. Then what do you mean by additive inverse? If I take a number and add another number to get its additive identity element, that means here the identity element of addition is 0. To get 0, what number is added to a given number is called its additive inverse. Usually additive inverse we get by taking the opposite sign. Observe here, if minus a by b is a rational number, then additive inverse of minus a by b is a by b. Vice versa, if a by b is the rational number, then minus a by b is the additive inverse of a by b. Therefore, we write like this. This is called as the inverse property of addition. Okay, inverse property of rational numbers on addition. Write the additive inverse of the following. Here I am giving few questions. See, the one is minus 7 by 19. You have to write the additive inverse of the following. That means, what should be added to minus 7 by 19 to get 0? Or What should be added to 21 by 112 to get 0? Observe here, minus 7 by 19 is additive inverse of 7 by 19. If I add 7 by 19 to minus 7 by 19, I will get 0 as answer. So, 7 by 19 is the additive inverse of minus 7 by 19. Okay. Same way, write the additive inverse of 21 by 112 children. How do you make me 1? 5 lemons are there. How do you make me 1? So, how you are going to make me 1? I will divide the 5 lemons into 5 equal parts. Yes. And I distribute each part to 5 among the 5 persons. Each one will get 1 lemon. Yes. So, when I divide 5 into 5 equal part, or when I multiply 5 into 1 by 5, I am going to get 1. Yes. Or if I take back all 1 by 5 parts 5 times, then I will get 1 as answer. In the same way, when I multiply minus 7 by 1 by minus 7 or minus 1 by 7, I am going to get 1. Or when I multiply minus 7 with 1 by minus 7, I am going to get 1. Here I am getting the multiplicative identity. One is the multiplicative identity of rational numbers. When two numbers are multiplied and if we get the multiplicative inverse, then we call those two numbers as reciprocal. Here 5 is the reciprocal of 1 by 5 and 1 by 5 is the reciprocal of 5. Minus 7 is the reciprocal of 1 by minus 7 and 1 by minus 7 is the reciprocal of minus 7. Observe carefully, children. So, how to get the reciprocal? If you interchange the numerator and denominator, you are going to get the reciprocal of the given number, children. So, here one more question I am giving. Identify the rational number to be multiplied to 8 by 21 to get 1. To get 1, which number I am going to multiply with 8 by 21? If we multiply 21 by 8, we get 1. Observe here. When 8 by 21 is multiplied by interchanging the numerator and denominator. 21 is the denominator, that becomes the numerator, and 8 is the numerator, that becomes the denominator. When we multiply those two, I am getting 1 as answer. Hence, 21 by 8 is reciprocal, or we call that as multiplicative inverse of 8 by 21. Okay. What is the multiplicative inverse of 0 then? Which number we have to multiply to get reciprocal of 0? Think. 0 don't has multiplicative inverse. T0 doesn't have multiplicative inverse. Yes, because you know 1 by 0 is undefined. Hence, a rational number do not have 0 as denominator. Hence, 0 has no multiplicative inverse. In general, if A by B is multiplied by C by D and we get the product as 1, we say C by D is multiplicative inverse of a non-zero rational number. So, except rational number, C by D should be a non-zero rational number. Then we have A by B as its multiplicative inverse. Okay. I think now you understood inverse property, children. Now I am going to give you few example. Write the multiplicative inverse of these numbers. Write the multiplicative inverse of minus 13, 1 by 5, minus 5 by 8 into minus 3 by 7. Here multiplicative inverse of minus 13 is minus 1 by 13. For the second one, you have to write the multiplicative inverse by interchanging the numerator and denominator. Here As in the case of additive inverse, we are not changing the sign, we are changing the numerator and denominator. For the third question, first simplify it, first multiply and simplify, you will get a number. For that number you write the reciprocal. Okay. So, in general we say if A is multiplicative inverse of 1 by A, then A and 1 by A product will be multiplicative identity or identity element of multiplication, that is 1 children. So, therefore, minus 13 into 1 by minus 13 is equals to 1, hence minus 1 by 13 is the multiplicative inverse of minus 13. Let us solve few questions, fill up the blanks. 3 plus 0, 3 by plus 0, this we have discussed in the previous class, that is in the second session. So, these are the question about identity element of addition, identity element of multiplication, multiplicative inverse and additive inverse. Try to answer these question on the basis of these properties, children. Okay. Next, observe here. I am multiplying 4 into 7 and I am getting the product 28. Yes, that means we know multiplication is repeated addition. Instead of adding 4 7 times, what I am doing? I am multiplying 7 by 4 and I am getting 28. I can do this in another way also. 4 into 7, I split 7 as 2 plus 5. First I will take 4 into 2, that is 8. Then I will take 4 5 times, that is 4 5s are 20. Then also I am getting 28. So, why I have to do like this? It may confuse you, but it is very much useful for the larger numbers, children, that we will discuss later. Okay. Now, observe 4 into 7 is same as 4 into 2 plus 4 into 5. We call this property as distributive property and rational number. Now observe by taking larger number 12 into 99. So, now what I do is I multiply 12 and 99 and I am getting the answer as 1188. Yes, let us keep this answer. Now observe, I am going to do in a easy way. I will write 99 as 100 minus 1. It is very easy to multiply the multiples of tens, that is 10, 100, 1000. 12 into 100 is 1200. Now I will subtract 1 time 12, that is 12 into 1, because I have written 99 as 100 minus 1. When I subtract 12 from 1200, I am getting the same answer, that is 1188. So, 12 into 99 is same as 12 into 100 minus 1. I think now you know the miracle of distributive property because it is very easy to do the multiplication of larger numbers. So, distributive property and rational numbers. Let us take example of 3 rational numbers and let us distributive property. Minus 3 by 4 into 2 by 3 plus of minus 5 by 6. What I do is, observe, I will take the LCM for 3 and 6, it is 6. Then 3 2s are 6, hence 2 2s are 4 plus of minus 5. That is when I simplify 2 by 3 plus minus 5 by 6. This we have discussed the addition of rational numbers in detail in the last 2 classes, hence it is very easy for you now. It is minus 1 by 6. Now, I am going to multiply minus 1 by 6 with minus 3 by 4. Minus into minus plus, 3 1s are 3, 4 6 are 24. If I simplify 3 by 24, the simplest form of this is 1 by 8. This is how we do actual multiplication. But now what I am doing? I am using distributive property. I am going to multiply minus 3 by 4 and 2 by 3. Then again I am going to multiply minus 3 by 4 and minus 5 by 6. Then I am going to add the result. Okay. When I multiply minus 3 by 4 and 2 by 3, I am getting minus 6 by 12. And when I multiply minus 3 by 4 and minus 5 by 6, I am getting 15 by 24. Now, when I simplify 6 and 12, it is minus 1 by 2, and 15 by 24, it is 5 by 8. If I take the LCM, or if I multiply the first fraction minus 1 by 2 by 4, I am getting minus 4 by 8. So, with the same denominator 8 as the common denominator, if I simplify the numerator, I am getting 1 by 2. In both the cases, I am getting the same answer. So, if I do this for the larger numbers, it is very easy. So, this property is called as distributive property on rational numbers, children. Okay. What does this distributive property on rational number says? If A, B and C are rational numbers, then A of B plus C is same as A into B plus A into C. If we consider the difference of B and C, A of B minus C is same as A into B minus A into C. Use suitable property and find the value. So, let us use the property that we have learned and we will simplify this question. Okay, minus 2 by 3 into 3 by 5 plus 5 by 2 minus 3 by 5 into 1 by 6. What I am going to do is, with the help of commutative property, I am rearranging the question. That is all, I am not at all done anything. I rearranged this with the help of commutative property. Now, I am taking 3 by 5 as common with the help of distributive property. Now, I am simplifying 2 by 3 minus 1 by 6 by making the denominator same. I am multiplying minus 2 by 3 by 2 to make it minus 4 by 6, which is an equivalent fraction for minus 2 by 3. Then when I simplify, you will observe 3 by 5 into minus 5 by 6 plus 5 by 2. Here 5 and 5 cancels, I am getting minus 1 as answer. Here 3 ones are 3, 3 twos are 6. Yes. So, if I cancel 3 and 6, I am getting 3 ones are 3 and 3 twos are 6. So, when I simplify this, I am getting minus 1 by 2. Now, I have to add this to 5 by 2. When I add minus 1 by 2 and 5 by 2, I am getting 4 by 2, which is nothing but 2. So, this how we used properties of rational numbers to simplify this problem. Okay. So, now write as directed. This is there in your textbook in page number 27. The rational number that does not have a reciprocal. Which rational number does not have a reciprocal? Think, children, now only we have discussed. It is, yes, it is 0. Second question, the rational numbers that are equal to their reciprocal. So, both the rational number and the reciprocals are one and the same. Which are those numbers? Think. If you multiply those two numbers, you are going to get 1 as answer. Okay. So, that is multiplicative identity. Here the two numbers are 1 and minus 1. So, the next question is like this. The rational number that is equal to its negative. So, the rational number and its negative both are one and the same. Which is that number? Yes, it is nothing but 0. So, there are few more questions in your textbook. You try to answer this question. So, if you come across any doubt, you please discuss with your teacher, children. Now, I am going to explain you or discuss with you an important point, that is representation of rational numbers on number line. We know how to represent natural numbers, because indefinitely the natural numbers extend at only one side, that is from right side of 1 indefinitely we have infinite numbers, but the other side we won't extend. If we discuss whole numbers, so the whole number set, when we represent on number line, the line extends indefinitely right side of 0. Okay. Next, if we talk of integers, we know the line extends on either side of the number line. Indefinitely, the line extends on either side of the number line. This we know. Now, how to represent the rational numbers on the number line? Let us think. So, we know number line extend infinitely, indefinitely on either side, yes. But we have numbers between 0 and 1 and 0 and minus 1. If I divide 0 and 1 into two equal parts, we know each part is equal to 1 by 2. In the same way, when I divide 0 and minus 1 into two equal parts, it is minus 1 by 2. Yes, you are observing it. In the same way, if I divide 0 and 1 and 0 and minus 1 into three equal parts, each part is equal to 1 by 3. 2 by 3 in positive direction and minus 1 by 3 minus 2 by 3 in negative direction. That means now we observe that the line extends infinitely on both the sides, but you can see numbers between minus 1, 0, 1 and 2. There are numbers between 0 and 1, 0 and minus 1, 1 and 2, minus 1 and minus 2. So, these are rational numbers. How to represent these rational numbers? Let us discuss with an example. Represent 5 by 3 on number line. Here the denominator is 3 and the numerator is 5. Here in the P by Q form, the value of P is 5 and the value of Q is 3. Now, draw a number line, mark 0, 1, 2, etc. I am considering only positive direction because 5 by 3 is a positive number. You know, when 0 to 1 is divided in 3 equal parts, again the same way I am dividing 1 and 2 into 3 equal parts. Each part represent 1/3. Yes. So, the second part is 2/3, the third part is 3 by 3, the fourth part is 4 by 3 and the fifth part is 5 by 3, that is highlighted. Now, you can observe the place of 5 by 3 on number line, children. Yes, this is how we represent the rational numbers on number line. Let us discuss one more example. Okay, representation of rational numbers on number line. So, I am giving you two methods. I am discussing method 1 now. Observe. In stage 1, what I am doing? I am marking 0, 1, 2, 3, 4, etc. on the number line. In stage 2, I am dividing the number line into 4 parts because the denominator tells us the whole is divided into how many parts? In 15 by 4, the denominator is 4, hence each number is divided into 4 parts. Stage 3, mark the parts. It is 1 by 4, 2 by 4, 3 by 4, 4 by 4, etc. Stage 4, identify the place of 15 by 4. This is the 15 by 4 on number line. This is one method and this is the easy method. One more easy method is there. Let us discuss the second method, children. Okay. In method 2, what I am doing? In the stage 1, I marked 0 to 15. Okay. This 0 to 15 is divided into two equal halves. Then the part that is marked, the center becomes 15 by 2. Again, I am going to divide this into two equal halves. Now, the each part is 15 by 4, 15 by 2, 45 by 4. Now, you got the place of 15 by 4. Yes, this is the 15 by 4 place on the number line. This is one more method of representing rational numbers on number line, children. Okay. Now, you know how to represent. We will discuss one more example. Represent 1 by 8 on number line. What I am doing? I am dividing 0 to 1 into 8 equal part. Each part is represented. So, the first part is 1 by 8. The second one is 2 by 8. Third is 3 by 8, 4 by 8, 5 by 8, 6 by 8, 7 by 8. Now, what is the place of 1 by 8? It is highlighted. That is the place of 1 by 8 on number line. Okay. So, I am going to give you two numbers, rational numbers, represents these rational numbers on the number line. One is 7 by 4 and another one is minus 5 by 6, children. You know, 7 by 4 is a positive number. It will be towards the positive direction. that means it is towards 0, 1, 2, 3, etc. It is improper fraction, it is more than 1, hence it crosses the 1. Minus 5 by 6, it is a negative number, it will be in the negative direction after 0. Since it is a proper fraction, it is less than 1, its place will be between 0 and minus 1. This is the clue I can give you. Okay. So, next we are going to learn how to write any 3 rational numbers between 2 and 3 and 4 by 5. I am taking 2 examples, but learn the method for any 2 rational numbers, how we are going to write the numbers between them. So, here the method 1. In method 1, in stage 1, I am converting 2 by 3 to a decimal. It is a recurring decimal 0.6, approximately 0.67. In the same way, 4 by 5, I am expressing 4 by 5 in decimal form, it is 0.8. Now, I am going to list the decimals between 0.6 and 0.8, that is 0.7, 0.73, 0.77. These are all the decimals that lie between 0.6 and 0.80. Now, express these again in fraction form. You are going to get 70 by 100, 73 by 100, 77 by 100, 80 by 100. So, these are the rational numbers between 2 by 3 and 4 by 5 children. So, these are the required rational numbers. This is one way of writing the 3 rational numbers between 2 by 3 and 4 by 5. So, the next method, observe here. In the method 2, what I am going to do is, I am taking the average of 2 by 3 and 4 by 5. When I take the average of these 2 numbers, I will get 22 by 30. Okay. So, when it is simplified, it is 11 by 15. Next, I am going to take the average of 2 by 3 and 11 by 15. When I take the average of 2 by 3 and 11 by 15, I am going to get 21 by 30. When it is simplified, it is 7 by 10. So, now I am taking the average of 11 by 15 and 4 by 5, the last number. Okay. So, I am getting 23 by 30. The required rational numbers are 11 by 15, 7 by 10 and 23 by 30 children. What is the one more method, and the easiest method is method 3. Here what I am doing is, I am writing equivalent fraction for 2 by 3, 10 by 15, 20 by 30. These are the equivalent fraction. When I multiply 2 by 3 by 5, I am getting 10 by 15. When I multiply 2 by 3 by 10, I am getting 20 by 30. Same way, when I multiply 4 by 5 by 3, I am getting 12 by 15. When I multiply 4 by 5 by 6, I am getting 24 by 30. So, I am writing equivalent fraction of 2 by 3 and 4 by 5 such that the denominators are same. If I consider 10 by 15 and 12 by 15, I will get only one rational number, that is 11 by 15 in between 10 by 15 and 12 by 15. For that reason, I am taking one more equivalent fraction, that is 20 by 30 and 24 by 30. Now, between 20 by 30 and 24 by 30, I have so many rational numbers, that is 21 by 30, 22 by 30, 23 by 30. We know 20 by 30 is nothing but 2 by 3 and 24 by 30 is 4 by 5. If you simplify 21 by 30 and 22 by 30 and 23 by 30, you are getting 7 by 10, 11 by 15 and 23 by 30 as answer. So, these are the required rational numbers. Children, till now we discussed these points in this chapter. These are all the points that we have discussed in this chapter. Hope you understood this chapter very well, children. Thank you. If you come across any doubt regarding this chapter, please do ask your teacher and clarify your doubt, children. Thank you very much. Myself Sucheta SS, mathematics teacher, T. Dasaralli, Bengaluru North 4. Thank you, children.